So introduction to databases, part 1 of 50. So what is a database? As a database is pretty much a digital store of data that's persistent, and it usually has some well-defined structure. You can think of it as kind of a electronic filing cabinet. And some examples of databases or uses of databases, like Facebook keeps your user data stored in a database, like hospital records that are digitized. Any data that is accessed on the web is pretty much in a database. So as far as what happens on the web, let's think about a regular website, where a client will make a request and that comes into the web server. And then the response is sent right back to the client. Now say if a client is submitting a user profile, to the web server, without the web server having, some kind of persistent storage, it's going to be sent to the server, and the server will craft some response, but all the data is not going to be saved. And you're not going to have a user profile to look at, unless you keep filling it out and going round and round like that. So that's where the database comes in. The database server will store our data. So when the response comes in, the web server will send a query to the database, and the database will perform some operation, whether it's storing that data or just retrieving the data based on the query. It'll send the data back, and then the response will include the data from the database. So essentially, the database persists data for web applications, and requesting data from the database will be sent back to the client. So, there are different types of databases. So the main two types of database fall in two categories. So it's relational database model, and there's the non-relational or NoSQL store. For most of our work, we use a relational database, and that's MySQL. When we do NoSQL type stuff, that's what we talk about when we use Mongo or DynamoDB. And they both have their pros and cons, and based on the nature of the project that you're doing, you might choose one over the other. Relational databases are very structured, and they're good for data consistency, and they have built-in integrity with data types and enforceable relationship constraints and limitless indexing. So if you have a table with 5 million rows, you can keep adding indexes and indexes, and your queries should still be speedy and responsive based on those indexes. Some drawbacks of relational databases: they don't scale horizontally very well unless you take pains to add infrastructure and do things like sharding. It's basically splitting your data amongst replicas that are read and write. So you'll read from particular instances, and you only write to a central point that disseminates the data amongst a group of database clusters. Some other cons of relational databases: the data is normalized, which can affect the speed of your queries. So you're using joins to get back information that is spread out amongst multiple tables. And it doesn't really work well with unstructured data. So if you want to, just dump a mess of data into a relational database, or like one row of a table, it's a kind of an abuse of a relational database, and it's not going to work very well for your application. So NoSQL databases, they scale horizontally very well, exceptionally well. And your data doesn't have to be in any particular schema. You can persist data in any structure you want on the fly. That might not always be the best thing, but you can do it. It has high availability, so it's very low likelihood of failure, for your application. And it does have limited support for transactions, which, transactions are units of work that ensure some kind of procedure to your queries. So they go in as you intend them to. Cons, there's, you're not really able to use joins in a NoSQL database. So in that regard, data is highly denormalized, which may require you to do mass updates. So if you, say if you have a product name and that product is referenced in multiple tables, you have to update that product name in multiple tables. And there's not as much data integrity enforced at the database level. You have to enforce it in your code. And there's limited support for indexing. So the database schema. The schema basically is your blueprint of your database. It describes how your database is laid out and how the data is organized. So in most databases, it's made up of tables, which are divided into columns and rows. So the columns, they label data and describe the types of data that will be stored. And your rows store the actual values in the database. So you can think of it as a spreadsheet. So a database table is basically a spreadsheet. So your schema is basically describing what your database looks like and the information it holds. And if it's well done, we can use certain functions in our applications to perform automatic inserts and kind of give us database objects if we're using a ORM, which is a object relational mapper. So if we're using something like Laravel or Symfony, we don't actually interact with the database directly. Our schema is informing our application, so we can use models to kind of persist objects that will, underneath kind of do the queries for us to insert stuff into the database and retrieve data. So that's why a good schema can be very helpful to an application. And a bad schema will sink your project very quickly. So when we talk about relational databases, there's many different flavors of SQL, and SQL is the structured query language, that we use to interact with the database and retrieve data. Most often we use MySQL, which is open source and free to use. And Oracle is another type of SQL, which they actually own MySQL now, but they are still keeping it open source. And they have their proprietary Oracle database And SQL Server is the MySQL version of SQL. So when we talk about querying the database, there's an acronym that we use. It's called CRUD. And CRUD is basically create. So if you want to add data to the database, you're creating a record. Read, you want to retrieve data from the database. Update, you're updating records in the database, one or many. And delete is you're removing data from the database. And you can do a soft delete where it's it will be inaccessible, but it is not permanently removed from the database. So data can be restored. Or a hard delete is it's wiped out from existence and you cannot ever get it back in most cases. I'm not gonna go further and get into like what SQL actually looks like in querying the database, but I guess now we can just go to questions if anybody has questions.